Hi everybody. Today our lecture will focus on the environment and its effects on human performance. We've already defined open and closed skills during our lectures, both in class and online. Today we're going to add another component to the understanding of Gentile's taxonomy and the environment. By the time we get to the end of today's lecture, you'll understand more about the second component that will help you to understand more about environmental effects. So, as we continue our journey of understanding skills, I want you to understand the differing environmental demands on each of these skills. So, what are the environmental constraints? These are the relevant factors in the environment that are either moving or stationary. We've defined these as either open skills or closed skills. And if you remember, Barbara Knapp referred to these as habitual versus perceptual skills. Closed skills would be habitual, open skills would be perceptual. So when we're talking about environmental constraints as they relate to being moving or stationary, we can ask the question, are the relevant factors in the environment moving or stationary? So if they were moving, an example of this would be dribbling a soccer ball or bringing down a wrestling opponent. Then it's an open skill because the relevant factors in the environment are stationary. Stationary skill examples would be bowling because the pins are stationary, the ball is in the control of the performer. And another example would be target archery. The target is stationary. The relevant factors in the environment are stationary. I want to remind you that one of our students asked a question about the wind or the rain. Certainly, these play a role in changing the environment when you consider Knapp's continuum. As you add in these other factors, if there is a lot of wind, then I would say a skill moves more towards the open part of the continuum. You can imagine a target moving because of the wind. In other words, it might fall over, right? Or in wet circumstances, certainly there are mechanical constraints that you have to consider as an athlete or a performer. But we're going to leave those out of our analysis right now because they just complicate the question. So what I want to do is isolate the question on whether the relevant factors in the environment are stationary or moving. So to further elucidate information about open skills, I want you to realize that in open skill performance, there are both spatial and temporal factors that are in the environment that are pertinent to the performer. Spatial means where things are in space, whereas temporal means the timing of things. Is the timing predictable? Is it unpredictable? Does the mechanical influence change the temporal factors? In other words, if a ball hits a wet ground, it will change the dynamics or the temporal factors of the movement of the ball because the ball will probably either skid on the wet surface or it might sink into the soggy surface. In open skills, also, predictability is limited. In other words, I have to wait to get certain cues either from the performer early on, my opponent, or I have to get information once these spatial and temporal factors are in motion. So an example would be playing softball as an infielder. There were certain cues to look for so that you could pick up advanced information about the direction of the ball. So I might look to see where the front foot of the batter is pointing, to get a good example of how open or closed, lack of a good term, how open the person's body is or closed off the body is to third base. In open skills, information processing is ongoing. In other words, there could be changes due to these relevant moving factors at any given time. So I have to really pay attention to those factors and be ready to make a change in my information processing if in fact a change is required. And finally, movement patterns tend to diversify, and we're going to come back to that as we move through this lecture today. In closed skills, only spatial factors govern performance. In other words, there are no temporal factors because there are no moving factors. There are temporal factors related to the person, the performer, and his or her body. In other words, how fast do I move my arm? How much do I swing my hips? However, that's not related to the relevant factors in the environment. Remember that that's where we are isolating our attention at this particular time. Predictability is somewhat unlimited. In other words, I could make predictions about the environment. Think about the basketball foul shot is a closed skill. I see where the teams are lined up along the foul lines or the boundary lines in the key. So that gives me a lot of information in advance in terms of how I would want to manage my free throw and where I would want to go after that. The relevant factors in the environment is stationary. We certainly define that. And the information processing demands are quite low because essentially I could pre-program this information and then just kind of let it run off once I get the stimulus to begin, or at any point when I decide to begin that movement. For example, in bowling, I stand at the line a couple of feet away, and then I take my three-step approach, and I release the ball at the line, and I have a very specific pattern that Wughalter uses when she goes bowling. So here's Sherry, a graduate of our undergrad and grad program. You've seen pictures of her in a football uniform. At any rate, how would you categorize the type of skill, open or closed, that is part of this agility drill that she's involved in here, running around these cones? I would say that it is a closed skill. The relevant factors in the environment, which are the cones, are stationary. She's moving through the cones, but that's unrelated to what's happening in the environment. Now, once one of those cones goes down, that somewhat changes what's happening in this continuous skill. So as she gets to the point of this last cone here, basically it could be a little bit of an open skill, but I would move that more on the continuum back towards the closed side of the continuum. So I also want you to take notice of the movement pattern that Sherry has in this picture. For example, I could say that based upon what I see in this picture and the shape of her muscle and what's being activated there, that she's driving downward and forward. And the drive forward is also evident from her forward lean. She also has contralateral movement. Notice how her left leg and her right arm are in the forward position, and then she's going to drive her right leg and her left arm forward. So we discussed this in class, what contralateral movement means. We could further describe the position of her feet, her ankles, her knees, her hips, and so on and so forth. So this description that I just gave you about what the movement looks like in terms of observing the movement, what the form is of her movement, this is considered the movement pattern. The movement pattern is measured by biomechanists, and they can provide very rich information to the area of motor behavior. So you start to see the influence of interdisciplinary work and technology on analysis in sport, in work, in play. In this picture, you could see a cyclist coming across the finish line. There's really nobody else in sight in terms of being competition for him. I would categorize this as a closed skill. The bike is probably becoming one. It's a very empty course. You would expect it to nobody to throw anything in front of him. And the fact that the bicycle is moving, I think that sort of becomes a part of his body and his experience. It's not really, he certainly has to anticipate it, and if he hit a crack, etc. But truly, I think that this is a closed environment. Now, in 2 slides ago, when we looked at that picture of Sherry, I started to talk about biomechanical analysis and the tools that are provided to many disciplines to create complex analyses of movement. So on this slide, you see a frame that was taken probably from sensor technology. But over the years, we've used film and videotape technology to do what's called movement analysis, and this is what biomechanists actually do. So imagine that this frame is one among many frames. Imagine that across time, the angle of the ankle, the knee, the femur, and the hip would actually change over time, and that this actually measures the gait or the walking pattern of an individual. So through video or sensor analysis, we could collect multiple frames per minute. I think that in our exercise physiology lab, we collect something around 240 frames per minute. And that's outstanding because in the motor behavior lab, I have an instrument to measure movement analysis at 33 frames per second. Imagine that in the Olympics, in very high speed cameras, they can get 2,500 frames per minute. You can imagine the greater detail that you would get in the analysis if in fact you had that kind of technology. So biomechanists actually use this video or sensor analysis to analyze movement patterns across space and time. By looking at the physical dimensions of the body and how they change, it allows researchers to understand really how the body moves. So you can see the importance of biomechanics in motor learning, especially with regard to how people learn or how people perform under a set of circumstances. So you can also see in this particular slide how movement analysis could be used for artificial intelligence. For example, you could see the human being here, And this person is actually all hooked up to a bunch of sensors that then is used to move the robot or move the animation. We've all seen recently films, animation films, where the animation is so incredible you really think you're watching the actor or actress who's in the animation. I remember the first time that I saw an animation, I was shocked by the reality of The Lion King. And I asked the person that I was sitting with, are those real or is that animation? And that's how the field of animation has grown. And towards the end of our semester, we'll talk about using movement analysis for different kinds of special effects and so on and so forth. So two researchers, Higgins and Spaeth, provided for us a new or a different way of looking at the environment. And what they did was they looked at whether the environment is changing or the same. And look at how the title of their paper is Relationship Between the Consistency of Movement. Does movement stay consistent and the environmental condition? In other words, closed or open skills. Recently, I was rereading this article from, look over here, 1972, and I get to the last paragraph of the paper, and it says, the vast amount of film used and data points collected in this type of investigation makes it imperative that the investigator have available an appropriate motion analyzer and a potential for direct computer linkage. The investigator must also be facile with computer technology and able to write his own computer programs for data reduction and specialized statistical analysis. Look at how far we've come in 48 years since 1972 when Higgins and Spaeth wrote this paper. And so what came out of Higgins and Spaeth's paper was this diagram. And what they showed was that early in practice, both open and closed skill performers have a large bandwidth of movement behavior. Late in practice, closed skill performers tend to fixate, while open skill performers tend to diversify their movement patterns. We're going to start with this particular diagram on Thursday, but what I'd like for you to do is go out to this Fosbury tape and watch that before Thursday's in-class lecture, and also this Huffman video before you come back to class on Thursday. We'll pick up right here. Looking forward to seeing you. Bye.